Hello everyone and welcome to Pupils Choice Classes. In this class, I Himanshu going to teach you a very important concept of class 10th, which is proving an irrational number irrational. So by looking to a number, we deduce that it's a rational number or an irrational number. But how to prove it in theory? It's a very important concept and it comprises 2 to 3 marks in your board examination. So let's just look into it right away. Okay. So to do such questions, we have to use the concept of contradiction. Now, what is the contradiction concept and what does it do? The contradiction method states that we take an assumption, we take a hypothesis, and then we negate that hypothesis. Okay. So let's just try this method right here. The question statement states that we have to prove that root 2 is an irrational number. So the negation of this is root 2 is a rational number. Okay, we have made an assumption that root 2 is a rational number. Okay, if it's a rational number, then it could be written in the form of a upon b. So root 2 is equals to a upon b, where a and b are co-prime. Okay, these two are co-prime. Now, the property of co-prime number is, in the co-prime numbers, their GCD or HCF. This is 1. Their GCD or their HCF is 1. Okay. Now, solving this root 2 is equals to a upon b further. Root 2 is equals to a upon b. We can square on the both sides. After squaring on the both sides, we have 2 is equals to a square divided by b square. Now, this b square could be transferred here. So, it will form a square is equals to 2b square. Now, 2b square, that means this term a square, this is even because it's a multiple of 2. If this is even, a square is even, then a will also be even. A is equals to even because square of an even number is even and square of an odd number is odd, like 2 square equals to 4. 4 is an even number and 3 square equals to 9. 9 is an odd number. Okay. Okay, let's move further. Now, this even number a could be written in the form of some number 2 multiplied by k, where this k could be anything like 1, 2, 3, 4, and by this we will be getting the value of a. So a is equals to 2k. Now we can replace this in our first equation. This was our equation number 1, and we can replace this value of a in this equation. Okay. So replacing it right here or right here is the same. So let's replace it right here. Okay. So a is equals to 2k. Then 2k square is equals to 2b square. Like this. Okay. Now this will get us 4k square is equals to 2b square. This 2 will cancel out with 4 and it will be remain b square is equals to 2k square. B square is equals to 2k square. Now, with this statement, we can say that b square is a multiple of 2. That means b square is even. B square is even. If b square is even, then b is also even. B is also even. If b is even and a is even, then their HCF or GCD is never 1. Because if both are even, then they will always be multiple of 2, because it's a property of an even number, that's just a multiple of 2. So if A is even and B is even, HCF is not equals to 1. If HCF is not equals to 1 and we have taken this assumption or this hypothesis earlier, then we are negating it. That means our hypothesis of taking root 2 is a rational number is wrong. If it isn't a rational number, then it's an irrational number. So this is how we prove that root 2 is an irrational number. Okay. So I hope you got the explanation in your head, and if you don't, if you didn't understood it, please rewind the video and rewatch it and write it in your notebook. Okay, do write it in your notebook. This will appear. This will be coming in your board examination, and you have to read it for the board. Okay. So this was a proof of root 2 is an irrational number. We will be dealing with more questions with this method, contradiction method, more extraordinary questions for our Olympiad series. Okay. So if you like this video, please like, comment and subscribe and press the bell icon. Okay. Bye-bye.